Hello guys, very good evening. Can you guys hear me? Let me know in the chat. Very good evening, Arad. Thank you, Nazmeen, for confirming. Hello, Nishant. How you guys are doing? Have you guys practiced last class questions? I know there was one little bit complicated question that was difference in subarray. Have you guys practiced that question? Hello, Nilanjan. Very good evening. Anyone practice last session questions? Or we have also discussed that we have to practice the linked list problem also. So anyone discuss that one? Guys, can you see and hear me? Thank you, Niranjan. Oh, thanks. I thought earlier. Okay, great, great. So yeah, I was asking, have you guys practiced the linked list problem? Because in the last class we have completed, I think, one little bit complicated query, like complicated problem that was finding out difference in subarray. So have you guys practiced all those problems, or anyone tried to solve today's linked list problems? Anyone? Guys, respond in the chat if you guys are able to hear and understand the question. Hey, hello Ekta. Okay, so very good evening, Ankit. Oh, okay. So yeah, actually, I was asking that anyone has practiced the linked list questions which we have in today's slide. I was doing my last class because I missed it. Ah, okay. Practicing that question. Great, Nishan. Great. What about others? I remember in the last class, I think the complicated query was that one, right? The difference in subarray. Yeah, that was little bit like needed little bit extra effort to understand it. So I hope you guys have practiced that problem and now you are able to understand it with code and with logic as well. Like because in that question we need to find it out the maximum and minimum all together, because when we are able to find out the maximum and minimum all together, then only we can get the subtraction, then we can only get the difference between the maximum and minimum, and that's what in that question it was asking. So that's why that question was little bit twisted, but yes. Okay, so tried merging sorted linked list but got failed. Okay, no problem. Today we will start with that problem only. Okay, Vishal. So that I think that's the only second problem which we stopped it in last class. So today we will start with that one only. Okay. So I hope everyone has joined now, so we can start it. So before that, anyone has any question from the previous class? Like while you guys were practicing or trying to solve the query and you guys stuck somewhere, or you guys not able to understand some lines in the code, I could quickly go over that and then jump into the linked list problems. Okay, so nobody has a problem, so we can jump into the today's question, the linked list one. Ah, yesterday all good. Very nice, very nice. Just the last question from the previous class. Yes, so from there only we will start, Arad. The last question was merge two sorted linked lists. So from that question we are going to start today also. Okay, Arad? Okay, guys. So let's start from that question. Okay. So let me share my screen. Are you guys able to see my screen now? Thank you, Vishal. Okay, so let's read the question first, then we will jump back here. Okay, so problem is they have given us two sorted linked lists and our job is to merge them in a way such that the resultant list is also sorted. Correct? So we have been given two linked lists. We can see here 1, 2, 3, 4, and let's draw them here. 1, 2, 3, 4, and then this single, it's a single linked list, right? So in single linked list, as we know that we have only value and address, right? And that address will point out to next node. That's what we are referring. This is the address which is pointing out to next node, right? So this is our first linked list. This is linked list first. I can write it as equal. And then we have another sorted linked list, which is 1, 4, 5, right? 1, 4, 5. Oh, let's draw it in the same way, right? As we draw it the first one. Let's just change the color. So 1, 4, and 5. And then null. I think we have lead code question also for this. Let me find out the lead code link also. Yeah, this one, I think, merge one. So we can like read it there also or implement it there because code should not be, yeah, this question is there. Okay. So see guys, what they are saying, same question I think. We have given two sorted linked list, list 1, list 2. And they are saying merge the two lists in one sorted list. One sorted list. The list should be made by splicing together the nodes of first two lists. So they are saying that we have to splice each node from these two lists and then we have to create a new linked list here. The list should be made by splicing together the nodes of, splicing means dividing or breaking it. So splicing together the nodes of first two lists and then we should get the return the head of merge linked list. Okay. So everyone understood the question that from that we have the two different linked lists here, and then the final output would be the combine of it. Like there would be a new linked list or in the same linked list as ever we want. So our final output would be like this: 1, then this one, then 2, then we can go for 4. Or I think yeah, they are saying that the final linked list should be sorted also. Let me read it one more time. Yeah, resultant list is also sorted. So it means after 2, 3 will come. 3, then 4, again 4, again 5, and then that will come. Correct? So let's quickly see the result. 1, 1, 2, 3, 4, 4, 5. So this is the question, guys. Okay, we can compare the question with the lead code also. You see 1, 2, 4, 1, 3, 4. So like 1, 1, then 2, then 3, and then 4, 4. Everyone understood now the question? So Najmi is saying 3. Yes. Why 3 is coming first? Because we are creating a sorted merge linked list. So that's why we are keeping 2 and 3 in the sequence of increasing. This final linked list is in sorted manner and it's increasing. Understood, Nadmeen? Everyone understood the question now? Okay, so let's think about it. I think in last class we have discussed about two approaches. Okay, in last class we have discussed about two approaches. So let's go with the first approach first, which is the easy one, which I believe it's not bit tough. So we will create a new linked list. Okay, so this is our output, and let's draw the line from where we will start our implementation. Okay, guys. So let's create a new linked list, guys, first. So this linked list name would be merged linked list or merged sorted linked list. Okay, like we can say it as a MSL, correct? And right now it's empty. It does not have anything, or we can say it just have infinite or anything, right? And right now this will have one head, correct? So this, if we create a new linked list, this will look like this. And if we are adding a data like infinite there, so this will look like this, right? Correct, guys? If we create a new, any explain this question? And you want me to explain again this question, Suraj? Okay, sure. You have just joined. So see, Suraj, this was the last class question where we got two sorted linked lists, 1, 2, 3, 4 null. Second linked list is this 1, 4, 5 null, and they want us to give the combine these two linked lists, and the final linked list should also be sorted. So you can see here. So 1, 1, then 2, 3, then 4 is coming, then 4, 4, next 4 is coming, then 5 is coming. That's what they want. Clear? Yeah. So what I did, I have created first a new linked list. Okay. And this new linked list is keeping the value as a infinite right now. Okay. So why we are creating this new linked list? We will traverse both of these linked lists and we'll add element into this linked list only in the final linked list. And then we will return this final linked list from here. That's what we are going to do. So let's take this two linked list again. Yeah, I think it's good to have it here. Yeah, 1, 4, and 5 and null. Correct. This is the linked list. So first, what we will do? We will take one pointer, which would be taking a head of this one. So L1 is equal to head. Correct. In similar way, we'll take one more pointer for this one. So let L2 is equal to head. So guys, this L2 is pointing out here. So this is L2 and this is L1, which is pointing out to head. Got it, guys? Got it? So we have created two variables. Human head would be null for our new list. Yes, the first node would be null. So head would be pointing out to that node which is having a data of null or infinite. Vishal? So we have created a new node and we want to give this node a value like that which is not in my list, because I'm creating a new linked list here. And I'm telling you guys, I'm just using this linked list as a reference here, Okay. At the end, you will see that I'm not going to return this node in my answer. I'm not going to add this node in my answer. I will just simply return this node's next. This node's next. Whatever will be there, I will return that as my answer. Okay. So let's see. So we have created first pointer here and second pointer here. So L1 is pointing out to the first linked list head, and L2 is pointing out to second linked list head. Are we good with that? Great, Likith, great. Are we good with that? Okay. So now let's start moving it out. So first, our condition would be like the final condition would be like this. While L1 equal to null and L2 equal to null, or is not equal to null. Sorry, is not equal to null. Correct? So till we get the L1 or L2 as a null, we will continue this loop. Till we get L1 and L2 as a null, we will continue our loop. Okay. So now what we need to do in this loop? We need to guys compare our L1 and L2 values. Whichever is greater or equal, we need to add that node into this new linked list. We need to add that node into this new linked list. Okay. So guys, one more thing we can do, we can take one more variable here, temp, which is pointing out to this node. So we'll take two pointers here. Like head is already there. Whenever you create a node, head will be already there because this is just the first node in the linked list. So head will automatically be here, and we will take one more variable here, which will be pointing out to same node, which has the temp. The name of that variable will be temp. Okay. So now what we will do? What we will be doing here, guys? We'll be comparing if L1 dot value, like whoever is greater in these two nodes, whoever is greater. So greater or smaller, because we need to get the sorted. We need to create a sorted linked list, right? So we have to first take the smaller one. So if L1 dot value is less than or equal to L2 dot value, correct? L1 dot value is 1, L2 dot value is 1. So whoever is lesser here, we will add that to temp. So temp dot next is equal to L1 because L1 is smaller here. That's why it will enter into this condition. So temp dot next is equal to L1. So now in this MSL, in the merge single linked list or sorted linked list, so first node would be this with head, and the next node would be added at this one. Just visualize it, guys. Now this next node would be added at one, added as one. Correct? And now you can see temp is here. Right now temp is here. That's why temp dot next is equal to L1. So temp dot next is equal to L1. Now what we need to do? We need to increase these pointers. So now first this L1 will move here. Now this L1 will move here. And then this temp will also move from here. That's why actually we have taken the temp. We are not like keeping our head variable further. So now temp will also move here, because we can add the next node from here to this list. So what we will do here, temp is equal to temp dot next. Temp is equal to temp dot next. So with this line, temp will be going into the next node, and then we'll move our L1 also. L1 is equal to L1 dot next. Correct? This is the first condition, guys. Now we need to check for second condition. When L2 is smaller, so we can write the second condition also, else if L1 dot value is greater than L2 dot value. It means L1 is greater or L2 is smaller. This time we need to add this one. So what we will do here? Again same thing. Temp dot next is equal to L2, and then with these lines, temp is equal to temp dot next. But this time we need to increase our L2. So L2 is equal to L2 dot next. Correct? So with these lines, we will continuously compare the values, and whichever is smaller, we will add it here. So like see, in the second scenario, when we will be moving into again, first we have added 1. We have moved our L1 here. Correct? Now we will again checking. L1 dot value is less than equal to L2 dot value. So right now L1 value is 2 and L2 value is 1. It will not go into this loop. It will go into this one. So again, temp dot next is equal to L2. So this one will be added here. Correct? And then we will move our temp to next node, which is temp dot next. So now temp will be here. Then we are doing L2 is equal to L2 dot next. Now our L2 will also move from here to here. Again, we'll do the comparison. Whoever is smaller will be added here. Whoever is smaller will be added here. So next time 2 will be added here, right? Because 2 is smaller, so 2 will be added here. Same thing, temp will be moving to next element. Temp will be moved here, right? L1 will be moved here. Guys, again see which one is smaller, 3 or 4? 3 is smaller, so we'll go for 3 this time, right? And now temp will be here, right? and our L1 will be moved to this place. Correct, guys? L1 will be 4. Again, we'll see which one is smaller or equal. So right now both are equal. So now L1 will first move this element here. We'll first move here, 4. Same, this line will run, right? This part, right side. And now our temp will again move to this one. And guys, our L1 will move to null. L1 will move to null. Correct. So now here this while loop will stop. Here this while loop will stop. Correct. So first tell me, till now did you guys understand? I'm not saying this. We have solved this question. There is still something pending because you can see this 4 and 5 are still not added. This 4 and 5 are still not being added. But we will do something for that also. But tell me, till now you have understood this part or not? Let me come back to chat now. We should take a variable to store the L1.next before assigning L1 to temp. Okay, you understood that. Okay. Sir, we can do this without new MSL. We need to think about this, but yes, definitely we can do that. Definitely we can do that without MSL also. We rather than taking it as a node, we can take this as a variable also, temp, and then temp.next. But yes, in that scenario, we have to like in that temp, we should have some like next and key there, or we can see without that also you can do. You can assign directly into this one in the L1 first node. You can take this as a MSL. You can take this as a MSL, and then you can continue these operations. You can continue these operations. So without MSL, we can also do that. We will add them in another while condition. Yeah, the remaining one. Yes, for remaining one, we will do that. I will do that. First, I want to understand this thing. Then I will go for the next one. Yes, we can do by inserting at middle and return L1. You mean the while condition part? Okay, we can do by inserting at middle and return L1. If you guys remember odd and even, there was one problem, right? Odd and even. In the last class when we were talking about the linked list, so we did something for odd and even, right? So I think we can use the same strategy here also for solving it out. I was having problem in implementing a solution with O1 space. Okay, Vishal. So you were trying with the like another approach where you were trying to take the L1 there. Yes, this is simpler than that one. Correct. It comes under the easy, right? You can see the complexity is easy here for this. So it's not tough. Okay, so till now we have understood this, right? But as you can see, still these two elements are not being added here. These two elements are still not being added or traversed till now. So what we'll do, guys, after completing this loop, we will check for if any one of them, L1 or L2, if any one of them are not null, because this loop will only end when L1 or L2, one of them will reach to null, or any one of them reach to null. There could be scenarios like the number of nodes in both of the linked lists are equal. In those scenarios, it might be possible that L1 and L2 could be both will be in the null, or there would be like in this scenario you can see some in some scenarios L1 could also go to null if L1 size is lesser and L2 size is bigger. So L1 will go to null, right? So what we'll do, guys, after this we'll put two loops while L1 is not equal to null. So this will check if L1 is not equal to null. And then second loop will put while L2 is not equal to null. Any one of them could be not equal to null. So in our scenario, you can see L2 is not in the null. L1 becomes the null. So this loop will not run. But for L2 it will run. So what we need to do, guys, we do not need to do anything. It's very easy. Now after temp, how these elements are coming, you just simply add them in that way. So what we'll do, temp.next is equal to L2. and L2 is equal to L2 dot next. So L2 will move here. First L2 is here. So this 4 will be added here, right? L2 is here. So temp dot next is equal to L2. So first this 4 will be added here, correct? And then temp. Okay, one more thing. Temp is equal to temp dot next. Yeah, one more line will be added here, which would be temp is equal to temp dot next. Because we need to move our temp also, right? We need to move our temp from here to here. So that's why I added this line also. So now this temp will be here. Erase it, right? And our L2 will also move because this line will also run. So our L2 will move from here to this element. And then we'll again add it because L2 is not null. So we'll again add the 5 here, correct? And then our temp will move here again. The same line will run. Temp will be here and L2 will go to null. L2 will reach here to the null. And now this loop will stop here. L2 will reach here. So now this loop will stop here, right? With the null here. So now what we'll do in a, see same thing you need to do here also for L1 also. So temp dot next is equal to L1. L1 is equal to L1 dot next. And temp is equal to temp dot next. Same thing, same line, but just for L1. And at the end, guys, you will just return MSL dot next. So MSL dot next, not MSL. Why MSL dot next? Because MSL has first element as infinite. We don't, yeah, this element. We don't want to return this element as our answer. So we want to return this one, 1, 1, 2, 3, 4, 4, 4, 4, 5, the sorted one. So that's why we are returning MSL dot next. Let me know in the chat, guys, where you guys has any, where you guys is stuck or any doubt. We have to compare. We have to compare. We have to compare. Yes, it means you are saying here, right? We have to compare. Yes, L1 dot values and L2 because we need to find out the which one is the smaller one. The smaller one will only be added into our linked list. So that's why we are first checking for the. That's why we are comparing it and then adding it into the linked list. Okay. Sir, instead of using a while loop, we can simply do if not L1. If not L1, temp dot next is equal to L2, and same for L2. Okay. If not L1, temp dot next is equal to L2, and same for L2. So, see, we need to do while loop also, right? Not the if one. Okay, 1 minute, 1 minute. You are saying, okay, understood. Hmm. Okay, so yes, I think why not? You're right. If not L1, L1 will be on the null and L2 will be pointing out to this whole linked list. Correct? So yes, I think we can do that. And same for that also. We do not need the next loop only. Let's think if anything is missing in that scenario. Well, let me see in the chat other. So the Waziri Sulikit is saying no, if else will not get repeated, they will only add one node. No, actually, they will add one node, but that one node has already the reference for other nodes, right? You can see if L2 is here, this has hold the reference for all the remaining nodes as well. So that should work. Let me see others' response, then we can try that also. So all the nodes will be added after that, okay. The nodes will be added after that. In new while loop, you're not comparing. In new while loop, you're not comparing. Yeah, in new while loop, Joseph, because in the because the L1 and L2 are already sorted. L1 and L2 are already sorted, and we have already traversed L1. We have already traversed L1. Now in the L2, whatever remaining element will be, all will be already sorted. So that's why we are not comparing in the second or third while loop. Okay. And then those new while loop. Okay. In the end, those while loop can be replaced. Yes, I understood that one. Okay. So now look at this thing. If we do temp dot next is equal to L2, all the nodes from L2 be added. Yes. That's right. That's right. Yes, Likit, that would be added. Yes, we can check that. We can quickly implement it. Okay, guys, so we will quickly implement it here. Okay, we'll check with both scenarios. So we'll start with uh, so we'll first take let L1 is equal to list 1. So this would be for L1 nodes, and then let L2 is equal to list 2. This would be head for second one. And before that, we can create a small merge linked list, which would be MSL merge sorted linked list. So new list node, right? So right now you can see this function will be called here, like this new list because this is the prototype function. So you will see that like similar like class in the JavaScript as we have class, similar that this function is also there with a capital L. The difference you can see with the capital L. All the regular function will start from small m, but all the prototype functions or like the right word I'm forgetting right now. I think function prototype or is one more thing is we say it. But yeah, it's like a class. As we create a class in JavaScript, internally they are the functions in this way. Okay, and you can see the by default values are 0. If we are not providing any value right now, you can see we're not providing any value. So by default value will be 0, and the next would be null. Okay, so okay, this is, and what after that what we did, we created one more pointer and we pointed it out to MSL only. You can see in the code we created one more pointer temp and then pointing out to MSL only. So now we have created this thing. Now we can go for our first this while loop. Okay, let's do that. So while L1 is not equal to null and L2 is not equal to null, guys, this is, see, our while loop automatically checks these things. So you know we can reduce this to this also. They will all automatically check that till we got any null value. They will always automatically stop it here. So you can write this way also, and you can write this one also. Okay, so let's now what we need to do first. We need to compare the value of L1 dot val, because they have the key as a val, right? So if L1 dot val is less than and equal L2 dot val, okay, so this is the first condition, guys. Yeah, we are taking this one. Okay, now what we need to do in the temp, yeah, in the temp dot next equal to L1, right? Temp dot next equal to L1, and then we need to move our temp and L1 both. So temp is equal to temp dot next, and L1 is equal to L1 dot next. Correct? We need to move our temp and L1 pointer. You can see these pointers we will move further. Now we'll go for else if, or else also will work here, because in this condition it will only come when L1 dot value is not smaller or not equal. So automatically it will come. So we do not need to write this if condition again, but we can write it, or it's our own choice. So temp dot next, or this time it will be L2, and temp again, temp is equal to temp dot next, and L2 is equal to L2 dot next. Yeah. And now we need to do, now we need to check this part which it has suggested to us. If not L1, then in the temp dot next is equal to L2, right? And again we can check for L2 also. If not L2, then temp dot next is equal to L1. We'll check this works or not, but I believe it should work. And then at the end, answer would be return MSL dot next. Okay, guys. So let's check it works or not. Okay, it works for this scenario. Let's look for other use cases also. Other example use cases. Let's see. Okay, it works here also. Let's submit it. Yes, it works. So that's totally right. Yes, that work. So very nice, Ekta. That's totally right. So I hope everyone understood this while loop is not needed, because because these remaining pointers, wherever L2 is left or in the L1 left, all the remaining values, we can directly add them because these are sorted linked lists, right? These are sorted linked lists. So wherever L2 is pointing, all the remaining nodes will be, we can access it with just one pointer. So we can simply add this pointer at the end of here. So we will automatically get all the remaining values. I hope everyone understood. Yes. Joseph, Arad, did you guys understood? Parag, Suraj. Parag has understood. Nice. Suraj, clear. Okay. Great. So I will update the code. I think I have the code with while loop. But yes, let's go with the. Where is the merge one? Yeah, this one. Yeah, at the end we have the while loop. So we'll update it to this one. Okay. So anyone wants to try for the approach where we do not need to take this extra node? Like you guys can try it on your time, but I am thinking it should work without the, if we are not taking this extra node here, the merge SL, merge sorted linked list, I am thinking we can do that. But you guys try it and let me know after that where you guys is stuck. So Vishal, you were trying, right? Where you got stuck? You were trying, right? Sure, Likit, definitely try it. I tried doing insertion in only list but got failed. Means you're saying you are trying to insert in the L1 and then you go like I didn't understand what you're trying to say here. Tried everything that came on my mind. Okay, no, that's fine. That's fine. So I'm thinking like if we can uh, see in the same loop, rather than having temp here, if we can simply uh, just giving you one idea, but I also have not tried it. But I am saying that you guys can try it later and let me know where you guys are stuck. So let's quickly take the notes again. This is for everyone. It's not like that one or two people should try. This will just open your mind, right? When you will try these things. So 1, 4, 5, right? And I think there would be way. I think we should not be stuck, right? So, so what we'll do, we'll take one variable till temp is equal to null. Okay. And then again, same loop while L1 and then L2. Same loop. I already explained till we got the null, this loop will continue, right? And then what we can do, we have to check the condition. The condition would be same. If L1 dot val is less than equal to L2 dot val, right? So rather than adding to temp, I was saying if we can add, rather than adding to the MSL, so first in this temp, take the L1 dot next, L1 dot next. So now temp will be here, right? L1 dot next, temp will be here and L1 will be here. And then add it L1 dot next, whoever is smaller. So L2 is smaller, right? So then add the L2 here. Let's quickly try it. L1 dot next equal to L2. And now L1 is L1 dot next equal to yeah. So now this would be 1 here. Okay. And problem is we have to add whoever is smaller, that should be added. But what we are doing, whoever is greater, we are adding that one here. You know, see L2 is greater or equal. See, this is an equal scenario, it will work. But wherever L2 will come smaller, in that scenario it will fail. Let's try it. L1 dot next equal to L2, and then we can make our L1 is equal to temp, right? So now L1 will move here. This L1 will move here, right? and L2 will be this place. Correct? Now this time see, this time L1 is greater. It will go for next loop, which is else part. And we'll do same there also. Temp is equal to L2 dot next. L2 dot next is equal to L1. I think it will not work. There is one scenario where it will fail. See now, for this scenario, which one is greater? 2 or 1? So this time, yeah. So 1 minute. Which one is greater? Yeah, 2 is greater, right? So we'll come here, and then what we are doing? In this, we are adding 2. Yeah, then it's correct, right? L2 dot next is equal to L1. So yeah, 2 will be added here. Correct? And now L2 is equal to temp. So now L2 will be moved here in this 4. Correct? Now the problem, I think it will come. Now let's again look for, let's go above, and let's look in these two, which one is greater? I think this one is greater again. L1 is smaller. So now temp will be L1 dot next. So temp will move here to this part, right guys? And then L1 dot next is equal to L2. Yes, this is problem. See, L1 dot next is equal to L2. We cannot add 4 here. We can't add 4 here. So we need to add the 3 here. So that's what I was saying. In this strategy, there is one gap is coming, which is see, in the above scenario, whatever the smaller, we will adding that one. You can see we will adding that one, whichever is smaller, we will adding that one. But here it is happening opposite. Whoever is smaller one, we are adding that one. Whoever is the greater one, we are adding that one. So that's the wrong here a little bit. But yeah, we need to think about it something. So we should not be adding the L2 here. That's what the point here. That's what the hint here. Okay, guys. Okay, guys. So you guys can try it and let me know in the link LinkedIn about your solution. Okay. Let's jump into the next question. Okay, so now our question is this. So we have given two linked lists and we are supposed to swap the element at nth position from both left and right. From both left and right. So what they are saying, I think this problem is available in LeetCode also. So we can go for that. I think I have the URL right. Because these three questions are only available in LeetCode. I didn't get any other question. So yeah, this one is there. So quickly remove this one. Yeah. Okay, so now Ekta is suggesting something, reorder linked list 143. Okay, if you're talking about the earlier one, 143. You're talking about this one, Ekta? Oh, this one is different. Yeah, this one is little different actually. Let me explain you this question again. So what they're saying, you have given the head of linked list and one integer k, and there we have to return the head of linked list after swapping the values of kth node. See guys, they're not saying the replace the node. They're not saying the replace the node. They're saying replace the values of node from the beginning and the kth node from the end. So that's why guys, this question is become little bit easy when they are saying you to replace the value of node, not the node. If they are saying you to not replace the node also, replace the node, then there would be little bit complex. We have to think about different scenarios. But right now they are simply saying you just need to go to those places and replace the values of those nodes. That's why it is not now. That's why this question is not becoming that much complicated. So let me first draw it here in the. So what was the question? 1, 2, 3, 4, 5. 1, 2, 3, 4, and 5. And then we have null here. Correct? Now they are saying we have given one integer value k is equal to 2. k is equal to 2. So now they are saying, guys, you need to find out those places from the left side or from the right side, or from the start or from the end. And once you find out those places, just replace the values of those nodes. So right now you can see, if I start from here, so k is equal to 1, k is equal to 2. This is first place from start, right? And now go from the end side. So k is equal to 1, k is equal to 2. And this is the second place, end. So we just need to replace these two values. And then our final answer would be 1, 4, 3, 2, and 5, and null. And these are the replaced values. I hope you guys have understood this question. You can see here 1, 2, 3, 4, 5, k is equal to 2. So 1, 4, 3, 2, 5. Same here 7, 9, 6, 6, 7, 8, 3, 0, 9, 5. If you will check from the, they are saying fifth position from the starting. So 1, 2, 3, 4, 5. This 7 will be replaced. You can see the 7 has been replaced with 8 because from the end side 8 is coming there. So now 7, 8 easily has been replaced here. I hope everyone has understood the question. Okay, sure. Let me repeat it. So Suraj, this was the linked list which has been given in the question 1, 2, 3, 4, 5 null, and they have also given us one integer value to us. K is equal to 2, and what they are saying, you need to start, you need to like in this linked list, you need to start from, you need to start from the start, like the head of the node, and go for these positions and find it out, like from the start and also from the end, from both sides. You need to you need to look for the positions of these wherever the nodes are in this position, and then you need to replace those or swap those, not replace, you need to swap those nodes, the nodes values. So that's why you can see this is our start, right? This is our head node. So from here, we went for these two positions. So k is equal to 1 here and k is equal to 2 here. So now we reach here. This is the start position. Or like we can say from the left side, something whatever you want to write from the left side. And then same way, we started from the end side also or from the right side. So k is equal to 1, k is equal to 2. So these are the two positions. You can see this one and this one. So you just need to swap these two values. So that's why the final answer is coming as 1, 4, 3, 2, 5. I will also take the second example. From there we can okay, you understood, right? Everyone understood now? Just swapping. Yes, we are just swapping this one. Okay. Yes, actually, these are not the tough questions, but yes, I will also, I will also ask to you guys to make it little bit complicated. I will tell you how can we make this question little bit complicated also. Okay, so first let's try to solve this one. Let's try to solve this one. Yes, second example. Okay, sure. Let's take the second example also. 7966. Okay, 79766 783 095. Correct. And k की value 5. The value of k is 5. So now just from the starting, let's check from the starting first. So k is equal to 1, k is equal to 2, k is equal to 3, k is equal to 4, k is equal to 5. So from the starting, this is the value which we got, where k is equal to 5. Now from the end, now start from the end. K is equal to 1, k is equal to 2, k is equal to 3, k is equal to 4, k is equal to 5. From the end, this is the value. Right, guys? From the end, this is the value. So now we need to swap these two values. We need to swap these two values. So now our output will look like 79668730095. And that's what you can see here, 7966873095. Understood, Parag? With the second example? Forget to consider k. No problem, no problem. So these two things will be given in the problems. One linked list and second the value of k. So it is saying we need we need the length of linked list for this, right? Yes, we can go with that also. Yes, that's the first approach. So see guys, the first approach is First approach is that we can first find out the length of whole linked list, right? So see, let's take the first example again, and from the see the approaches from there. So 1, 2, 3, 4, 5, and null. So what would be the length here? So length would be 5, right, guys? 1, 2, 3, 4, 5. So 5 nodes are there. Length would be 5. Correct? So what if k is equal to 6 here? In this case, we will simply return null. That because our k's value is greater than the length. So we will simply return the null there. Understood, Arab? This is the edge case. If the k value is greater than, because we do not have any element there, like that. So in that case, we will simply return the null there. If k is equal to 6 in example 2. Oh, okay. If k is equal to 6 is there. So yeah, in this example, if k is equal to 6, so where we will come? So 1, 2, 3, 4, 5, 6. So 8 would be here, right? And 1, 2, 3, 4, 5, 6. I think same answer, right? 8 and 7. These would be swapped. Same answer, I think. Parag. Yeah. We just need to reach the node and then change the value of those nodes. Okay. Okay, guys. So, so now length is equal to 5 here. Correct. So now what we can do, guys? So from the starting, it's easy, right? We can take one pointer and we can reach to the second node. So this would be pointer from left side. Correct, guys? This is a pointer from the left side. Now we already know the length of it. We already know the length of our length of our whole linked list. So length is 5. If we subtract it from here, so 5 minus 2 would be 3. Right, guys? 5 minus 2 would be 3. So so third node, it will give us 3, right? So 1, 2, 3, 4, 5, right? And if we start from here, so we'll reach 1, 2, 3 and 4. Okay. So I'm thinking like 1 minute, guys. Yeah, I think. See, from this node, if we start from this node, from ahead, and we just traverse 3, I think we'll reach here only, right? First time here, first time here, first time here. Correct. Let's check this scenario with this example. 7, 9, 6, 6, 7, 8, 3, 0, 9, 5. So, so first we'll put the loop in the k value. With that, we'll take the loop with k value. So we'll reach here 1, 2, 3, 4, 5, right? And total length is 10. Total length is 10. So if we start from here again, so like we are just starting from here. So 1, 2, 3, 4, 5 will reach here. If we take the example of 6 also, so 10 minus 6 is equal to 4. So if we start from here again, so 1, 2, 3, 4, yes. So just we need to think about, we do not need to consider the first node while traversing for the length. Understood, guys? While we are going with the logic of length, we just need to skip the first node. We have to start from that node. You can understand, right? With the examples, everyone can understand that thing. Yeah. See, there is one another way actually. There is one more way to do that. So 1, 2, 3, 4, 5, and null. This was the length way. This is another way. So again, we'll start the same. While minus minus k, or like k greater than 0, something like that, while k greater than 0, and what we need to do here, we'll take this one as a temp. So temp is equal to temp dot next. So value of k is 2. So temp will be, after this loop, temp will be this place. Here, temp will be here. Correct, guys? Now they have given one more way, which is take two more pointers. Take two more pointers. So one pointer would be here. I'm taking this pointer as a last and this pointer as a start or right, because we already got the left, right? This temp is the position from the left side, so we need to reach the right node. So now guys, we have now when we take in the two pointers from here, we just need to traverse them one by one. We just need to traverse them one by one. Wherever last will reach to the null, right will always be at the correct place. So let's see that. So now right will be here, right, and last will be here. Correct? Again, next time I'm showing here. Right will be here, last will be here. Right? One more time I'm showing you. Right will be here for the last one. Right will be here and last will be at the fifth. And last dot next is equal to null. But we will stop here. And now you can see automatically you have reached to the right place. You do not need to count the length here. With this approach, you will also reach to answer. Because why this approach is working? Because you have already maintained the gap. You have already maintained the gap from the left side. See, if you have already maintained the gap from the left side, then if you are starting now again, if both people, let me tell you, if this is the race track, 1, 2, 3, 4, 5, 6, 7. So if if one person is starting from here, 3, if this position, and if one person is starting from here, and they both are running from the same speed, if they both are running in the same speed, so always this gap will be maintained, right? Always this gap will be maintained. Everyone agree with that? If from this place, if both players are running in the same speed, always this gap will be maintained. Correct? So that's what actually we did here also. So first we have created the gap, and once we created the gap, we have taken both places. Like this place, we have started one person from here. We started from here, and then we started moving both together. And once this person reached to the null, it means this pointer wherever it will be would be the right. It would be the right element which we need to swap. Understood, guys? The second approach. Second approach, everyone understood? Let me explain you again with a bigger example. This one, 7966. Let's take this one. So 7966 783 095 095. Okay, and our k value is 5. So what we need to do? First, we need to reach from the left side. First, we need to reach from the left side, that position, because we need to create the gap. So that's why first start from here. So this is the left side. I can say this pointer is left. So 1, 2, 3, 4, 5. So left will be here. Right, guys? Left will be here. This is this position, first position. Oh, sorry, this is this position. Second person is standing there. Correct? Now already we have the gap. We already have the gap. So now the new person, which we are starting from this position, now this gap will always be maintained if we are running in the same speed. So that's what we are doing. We are just going one by one. So now let's start. We have taken again this pointer as a last pointer, and this pointer is the right pointer, right? So now last will be increased. So now everyone understood, guys, this approach first? Did you guys understood this one, the scale one, where I was saying that the person who has maintained some gap while starting their race, if they both are running in the same speed, so they will be reaching at the end with the same gap. Did you guys understood the first one, the scale one? The gap will always be same between them, right? So that's what the idea is here, guys. So now you can see here. Now first we'll move our last further. Now this last will be here. Now this right will also moved. This right will be here. Again, last will be moving further. Last will be, it was here only. Last will be moving to this place. And right will be moving to 6. Correct, guys? Again, move this pointer further. Last. Again, move our right. Here. Right? Again, move this pointer to here. Last. Again, move our pointer to this one. Oh, right. It was right. Again, move our last to this, to 5. And now here last will be stop. And again, move our right to this one. So now last will be stop because last dot next is equal to null. So we'll stop our last when the next is coming null. And then we can see both positions we have. And then we will simply replace the values of these two nodes. 8 to 7, 7 to 8. Like this. Understood, guys? Yeah, we can say we have taken 3 pointers here. One pointer for keeping the left position and 2 pointers for reaching to the last element or reaching to the right element. This pointer and last pointer. Okay. Is this problem in LeetCode? Yes, this problem is here. Swap node in linked list. Yeah, it's here. Let's quickly solve this one also. It's not tough. So let's solve it. Let me, should I try to solve it, guys? Or do you guys have any doubt first? Tell me in the chat so I can explain the method one more time. You guys can solve it? No doubt, logic is clear. Okay, so guys, if you guys are solve it later, then let me tell you, let me make this question little bit complicated. See, once you will reach to this node, so it's very easy. Now you need to take like let temp is equal to left dot value, and then once you have taken this value, then you can update the left dot value is equal to right dot value, and then right dot value is equal to temp. You just need to write these 3 lines at the end, and your linked list will be swapped. You both of the nodes will be swapped. At the end of the once you got those 2 pointers left and right at the correct positions, you just need to run these 3 lines. Because we just need, because in the question is what it was saying that we just need to swap the values of those nodes. Okay, so that's why we have just simply swapped the values. But now we'll make everyone understood this thing first. Everyone understood this thing? Swapping the value of node. Understood, right? So now let's make a little bit complicate this question. And now the question is, you do not need to swap the values. You just need to swap the nodes. If your question is, you just need to swap the nodes, what would be your approach now? If say they are saying in the same question, if they are saying you do not need to swap the values, you have to swap the nodes this time. So what should be your approach, guys? What should be your approach here? Right, guys? So see, guys, take a temp variable. Even rearranging 2 nodes would be easy. Rearranging 2 nodes would be easy. Okay. So guys, first think about, if you want to remove a node, what are the things you needed? If you want to remove a node, what are the things you needed? First thing, you always needed a previous node, right? Let's take an easy example. 1, 2, what was that? 1, 2, 3, 4, 5, right? 1, 2, 3, 4, 5. Correct? This was the example. Let's take. And like same way, left was there and right was here, right? Left was there and right was here. Everyone agrees with that? So before replacing a node, if you want to replace this node, you need to break this connection, right? You need to break the previous connection also. So see, this 4 will come here. The final output will be this, right? 1, 4, 3, 2, 5. So what I'm trying to explain you guys, this first you somehow you need to find out the previous nodes, right? Like previous of right or previous of left. Correct, guys? Once first you need to find out these two pointers, previous of left, previous of right. And once you find it out, previous of left and previous of right, and then you can simply, now you know that, right? Previous dot left dot next is equal to right, right? You will make this connection now, like this. And same for here, previous dot right dot next is equal to left. Correct? You will write code something like this. Previous underscore L means previous underscore left dot next is equal to right. Right? So this connection will be ready. And then for this one also, previous dot right dot next is equal to left. And some more connection. Some more connection might be needed here. Correct? Understood this, guys? You need to reach to the previous node, and I know you guys know that, you know the logic how to reach the previous nodes. So while you are doing the while loop for L1 or L2, any of the linked list, you just need to do their previous is equal to L1, and then L1 is equal to L1 dot next. So always this previous node will be in the previous node. Always this previous pointer will be on the previous node. So you know that, right? First, first tell me in the chat, you know about finding out the previous element. I think in the first linked list class, we have already discussed about finding out the previous pointer. Everyone know about that, right? So no need to explain it further about the previous node, how to find out the previous node. Anyone? Everyone know about it, right? Okay. How to find left and right net issues. Okay. Let me first explain to Joseph about the left and right. Otherwise, he can't understand the further things, right? In meanwhile, you guys just think about, in meanwhile, whoever is understood this thing, just try to understand this will give you the solution or not. And I'm giving you one more hint. You need to do something more in that. After finding out the previous left, previous right, and left and right, 4 pointers you have already have, but you need to do something more there. Because guys, your left node could be the head also. So you need to change the head pointer as well. So that just think about it. In meanwhile, let me explain to Joseph or others how to find out the left and right. Okay. So Joseph, so we have this linked list 1, 2, 3, 4, 5 and null. And our question was, they will be giving us one value like k is equal to 2 or k is equal to 3, something like that. And then they will ask us, you need to find it out from the left side or from where the linked list is starting, that position, which is the value they have provided. And also you need to find out from the right side. Okay. So like in this example, you can see k is equal to 1 here and k is equal to 2 here, right? So this would be the position from the left side, right? And then from the right side, we'll do the similar thing. K is equal to 1, k is equal to 2, correct? And this will be the second position. So after finding out these two positions, we do not need to do anything. We just need to simply swap the values here. Swap the values here. So after swapping the values, they will look like this: 1, 4, 3, 2, and 5. You see, we have replaced the values. So that was the question, Joseph. Understood? You understood the question, Joseph? Got it? Question? Okay. So now you want me to explain how to find out also? How to find, okay. You want to understand the find part. So see guys, see Joseph, what we did for finding out the left, it was easy. For finding out the left, it was very easy. Why? Because you already have the value of k is equal to 2. So you will simply start the loop of while minus minus k or k minus minus anything you can do here. but you have to check minus minus k, I think will reach here only. But if you will do the k minus minus, it will be reaching here. Last node will also run. So that's why I'm doing the minus minus k. Specifically, I'm doing minus minus k. There is one reason for that. If you will not do k minus minus, then you will reach to the next node. Correct? So that's why I'm doing the, or what you can do, you can start from k less than equal to 2, and then you can start your k or temp variable or any variable, any pointer you can take I. You can take any pointer here, I is equal to 1, and then you can put condition here, I should be less than 2, less than or equal to 2. Then only you can see 2 time will not 2 k, I less than equal to k. You can do this also, and then internally you can do I plus plus, and then this will be our linked list L1. L1 is equal to L1 dot next. So what I'm doing here with this loop, I'm just simply reaching to this node wherever the key, from the left side, whatever the position is. Okay. After that, what I explained, Joseph, that if you just consider there is one line, 1, 2, 3, 4, 5, 6. Okay. If we have these two positions, and if one person is standing here, person 1, and if one person is standing from here, person 2, and now if both person are running at the same speed, they will always maintain this gap. They will always maintain this gap. So right now, like the time 1 or first minute, they are here, right? In the second minute, the third would be here because they are running at the same speed. P1 and the P2 will be here. You can see same gap is here also. So that's what, for finding out the right person, we already maintain the gap. We already have two gaps here. So now what we'll do, guys? Now what we'll do here, Joseph? We'll take one pointer again from the head of our linked list, and that pointer would be right. And the second pointer will start from wherever we find out the left position, and that we can keep it as a last, and then we will move one by one pointers. Once last is reaching to null, we will be, whatever the position of right is, we'll say that that is the right position. It's because you can understand this logic, because we have already maintained the gap. So wherever the last position would be, that would be the same position from the starting, and same from the starting. So whatever k is equal to 2 here, so k would be 2 from the right side also. Understood now, Joseph? How we have find it out the left and right? Great. Okay, guys. So let's come back to the previous one. Anyone thought about? Is there any possibilities which I think about, which I told you after finding out all of those 4 pointers, previous left, previous right, and right? Can there could be some more possibilities? Yes, definitely there would be more possibilities, because we need to update our head as well, because there could be some possibilities that our head node could also come under the same scenario. Right, we might need to replace our head node also. So I think that's what that's what actually one scenarios are there, and then after that I will leave it to you guys to think about more scenarios could be there or not. Okay. I will leave it to you, leave this to you guys. Okay. So now let's jump into the next question, guys. Can we jump into the next question now? Okay. So let's jump into the next question. I think that question I didn't get in the lead code. Till now, I got in the lead code. Okay, so now this question, what they're saying, given a linked list and value k, again they are giving one value k, we have to perform a right rotation such that the kth node reaches the end of linked list. Kth node reaches the end of linked list. Okay, so they have given this example 1, 2, 3, 4, 5, and the value of k is 3. And then they are saying, this time they are saying kth node, not the value of k. Guys, they are saying kth node, and then you can see once they did the right rotation, the 4, 5, 6 has come into the first, and 1, 2, 3 has reached to the last. So let me show you with the example what they're saying here. So now we have this linked list, guys, 1, 2, 3, 4, 5, 6, and they have given us value to us, k is equal to 3, and they are saying we need to do the right rotation. We need to do the right rotation, and we have to do the right rotation in a way so the kth node, this kth node has to reach to the last. We can read kth node. We have to do the right rotation such that the kth node reaches the end of linked list. Reaches the end of linked list. So it means, see, if we do first time rotation, first time right rotation, first time right rotation. So you know what will happen? This 6 will be rotated here. So it will look like this: 6, 1, 2, 3, 4, 5. This is the first right rotation. Right rotation. This side. Second right rotation. So this will look like 5, 6, 1, 2, 3, 4. Correct? Then we have to do the third right rotation. And then you can see 4, 5, 6, 1, 2, 3. That's what they want. That's what they want. That's what they want. That the kth node, whatever the kth node is, that node has to reach to last. That node has to reach to last. Everyone understood the question? They are saying lead code problem rotate list. Rotate list is there. So that rotate list, see, in that rotate list, they are asking little bit different. Likit. The rotate list, they were asking little bit different there. They were saying to you, you have to do rotate that many times. See, they are saying you have to rotate the list to write by those places. But in that place, they are not saying the node has to reach to the last. They are not saying, you can see in this example, they have given k is equal to 2. According to k is equal to 2, value is 2 here, but you can see at the end, the node is not coming 2 here. That's the example. That's why, yes, rotate until that kth node next become null. Alright, kth nodes, okay, you have written next, sorry. Yes, you're right. Kth node next become null. Okay, yes. Actually, this is not difficult. The rotation one could be a little bit difficult, but this one is easy. I will tell you how. Okay, guys, so that's what they are saying. Wherever the kth node, you can read the question again. That's why I didn't get this question anywhere. So given a linked list and value k, perform a right rotation such that the kth node reaches the end of linked list. Okay, guys? Everyone understood now? Everyone understood this question now? What about others? Okay, Arad has understood, Suraj has understood, Vishal. Parag, you have understood? He has left the chat, I think. Okay, so guys, let's think about. I think this one is not that much tough. So this was our linked list: 1, 2, 3, 4, 5, and 6. And then we have the k is equal to 3. So what we need to do, guys? We need to make, and what is our output here? Output 4, 5, 6, 1, 2, 3, and null. Right, guys? This is our output here. Okay. So let's you guys think about what could be like the easy way which is coming into your mind. And you have just remember, you have the value of k. It means you have this node. It means you have this node position. Now think about any ideas coming into your mind. You have this node. If you have this node position, any idea which is coming into your mind? So we can store the kth node in temp variable. Okay, so kth node be okay, and then rotate until the temp dot next become null. Okay. Okay, so temp rotate. Okay, and then whatever is coming before that, like you reach to the kth node. What about the before that? Like what about the 2 and 1? You reach to the kth node, which will be 3. Then you are rotating it. See, once you will rotate it, after rotating, it will look like, and see, how many times you have to rotate it. That's also you do not aware of. How many times you have to rotate it? 1 time, 2 time, 3 time? No idea. Okay, so now Vishal is saying kth node dot next is equal to head. Hey Vishal, you are seeing it somewhere, huh? Kth node dot next is equal to head, and last node dot next is equal to previous head node, because kth node is written in slide. Okay, so but still, yeah, find it out. So kth node dot next is equal to head. So kth dot next is equal to head. Kth node next not next is equal to head. Hmm. Vishal, if you're saying about kth node dot next is equal to head, so see, kth node is this one, third, right? Am I right? Kth node is this one, and kth dot next is equal to head. Okay, so head would be here. Kth dot next is equal to head. No. Kth node dot next is equal to head. It means you are creating a cycle here. So 1, 2, 3, and kth node dot next is equal to head. It means you are creating a cycle here. That's not right, Vishal. Your first line is not right. Okay, it means it's not from the. It also proves that it's not from the slide. And last node dot next equal to previous. So yeah, with the first line, yeah, that's fine. That's totally fine. That's totally fine. Because the kth node terms actually it is written in the slide, so that's why I got it. Yes, but you understood, right, Vishal, that it could create like a cycle there. You understood, right, with the first line. Yeah. Okay. Okay. Let's read the Likhit answer. So take a count where and iterate till count is equal to k. Okay. So we have iterated till count is equal to a, and add start at last and remove start node. Uh, Add start at last. So Likhit is saying first you reach to that node. So we have reached to this node 3. Then he's saying add start at last. So you're not saying that, okay? So it when you say iterate till count is equal to k, what does it mean? You mean you are saying inside that we need to follow these steps. Add start at last and remove start as node. Right? That's what you're saying. Yeah, understood. That part I understood. Count is not equal to k, and we need to do these things inside this loop. Add start at last and remove start node. Right? That's what you're saying. Inside that loop, we need to do this. Hmm. So okay, so what Likhit is saying, while we are traversing, so let's think about it. So this is our linked list: 1, 2, 3, 4, 5, 6, null. So while we are here, so he's saying add start at last and remove start node. So we need to take one pointer for that, right? We need to take one pointer for that, right? And add start at last. So somehow he wants 1 at the end and 2 here, something like that he wants, because he's saying start add at the last, right? So Likit, it will look like this. 3, 2, 1. Okay, let's see what Ekta is saying. Sir, we'll count from kth node. From kth node, you are okay. From count from kth node till last node, and count that number and then rotate that many times. Okay, understood. Yes, that could one way. Yes, Ekta. So Ekta is trying to give us answer for the first suggestion which she has given, and I think that there was only one problem, or there was any other problem. So 3 was there. Then yes, I think that was only the query that we need to rotate that many times. Yes. Can you paste the question in the chat? We'll read again. Okay. So Likhit is trying something else. Okay. So guys, you like all of your suggestions are very nice. So let's look into this one. Yes. Okay. So guys, what we'll do, we'll definitely traverse till that node. We will definitely traverse till, I can say, uh, yeah. So this is our temp node where we are right now. 4, 5, 6. So guys, what we'll do here, there, after this, we'll take one more variable here, like next. And in this next, we will save temp.next. So once we'll save temp.next, all these elements are in this next variable. All these elements are in this next variable, next. Now we do not need to rotate anything. We already have this whole linked list in this variable. We already have this whole linked list at the right side. I think Ekta has already given this answer in the first question when we were doing the merge to sorted linked list. So that same way we are going to do here also. All of the right side content we already have in this next pointer. Now what we need to do in this next pointer, once we have all the this next pointer will be here, which is pointing out to whole linked list, remaining whole linked list here, right? Now we just need to make this temp to null. So temp dot next is equal to null. So now this 3 will be mapping out to null, and then guys, this we need to just simply traverse this linked list. So now see guys, this is the linked list which we have with the null next pointer, with the next pointer. So we just need to traverse this linked list now, the smaller one, like L1. We can take the L1 here. Now we just need to traverse this L1 here. So once the L1 reaches to null, or here, once the L1 reaches to here, we just need to add this dot head, this dot head. So now our loop will look like this. While L1 dot next is not equal to null, L1 is equal to L1 dot next. So once L1 reaches here, we'll do simple this thing, guys. L1 dot next is equal to this dot head, or head. L1 dot next will do head, and yeah, and this next, this linked list, the remaining linked list, I can write it as remaining, right? And here I will write it like remaining is equal to head. Now this will become our head, and now the final linked list will look like 4, 5, 6, 1, 2, 3, and 3 is 2 null, and there our head would be. This was that much easy, actually, that much easy. So temp dot next is equal to null, last node dot next is equal to head. Yes, totally right. Head is equal to last node. Okay, let me explain it again, guys. Not a problem. Let me explain it again. So now our linked list look like this: 1, 2, 3, 4, 5, 6, and it is pointing out to null. So what we did first, guys, our k was 3. So first we reaches here at this place, and we kept it as a like temp variable. So now temp is here. So now what we did, we have taken the remaining remaining this linked list in one pointer, and that pointer is, or that variable is remaining node temp dot next. Correct. So now this remaining node is pointing out to this 4, 5, 6. Now this is pointing out to this one only, 4, 5, 6 null. This part only. Okay, remaining node. Now we have, and here we have our head. Correct. This is the whole linked list. So now we need, first we need to make this 3 to null, because in our answer you can see 3 is pointing out to null, that particular node. So that's what we did. Temp dot next is equal to null. This is the first line we did. Now once we did this line, our starting linked list will look like this: 1, 2, 3 and null. And here our head would be. Okay guys, this will look like this. Now let me change the color. Now what we'll do, guys, because we need to add this linked list at the end of this remaining nodes, because our answer is 4, 5, 6, 1, 2, 3. Where was that? Answer is, yeah, our answer is this: 4, 5, 6, 1, 2, 3. So now what we'll do, we will reach to this node. So for that we'll put our loop, while we'll take this remaining node in one more pointer, L1 or something like that. So whatever you want to take, we can use the temp again if you want, because now there is no purpose of temp. We can use the temp again, or temp 1. Let's take temp 1. Okay, so till temp 1 dot next is not equal to null, so it will be reaches here. We'll do temp is equal to temp dot next. Temp 1 is equal to temp 1 dot next. Okay, temp 1 is equal to temp 1 dot next. So once it is reaches here, temp, so we just simply add it here. This head node will add it into this one. So now temp dot next, which is null right now, because that's why you can see temp 1 dot next, sorry, temp 1 dot next is equal to null, which is you can see easily it's null right now. We'll do head here. So now this whole linked list will be added. After writing this line, this will look like this: 4, 5, 6, 1, 2, 3. Now we just simply need to make, still our head is here. Still our head is here. So we need to change this head to this place. So now what we'll do, head is equal to this one, remaining node. Correct? So now our head will become this remaining node, and this will be our answer. Everyone understood? I always confuse in this dot next, this dot. See, this dot, Ankit, I use this dot only when we are taking class. Like if you remember, in the single linked list, we were taking this class, right? So whatever we are doing inside this class, so we want to access these properties of this class: head, tail, length. So we can only access these properties with the help of this. You can see all these properties. If you want to access inside the class, we have to use this dot. But you know why we are not using it here? Because we are right now referring to the here to the lead code problems. So they are not saying us to use this or anything here. They are passing this whole head as a array here. They are passing. They are internally. I am telling you, they are internally using this dot only. But here they are simply passing it as a array to us. In that array, they already have dot next. So we do not need to use this there. Okay, Ankit? If you're talking about this only, if you're talking about this dot next, dot head, dot null, I have not talked about till now. But I think you can come into the mic and you can tell me about your doubt, Ankit. You got it? Okay. See, the confusion could be two places, two or three places. I think I already cleared those confusions. So one confusion was sometime I take while L1 is equal to null. L1 is not equal to null. Sometime I take while L1 dot next is not equal to null. That is one confusion which I already cleared it out. Second confusion which I explained to you, sometime I am assigning L1 is equal to L1 dot next, or sometime I'm doing L1 dot next is equal to L2. So these two also are different. These two are different, and these two are also different. And we already have discussed about it in last class. In last means in previous classes. I hope you guys are aware of these four differences. Are you guys aware of these four differences? Are you guys aware of these four differences? L1 is not equal to null, L1 dot next is not equal to null. These four, Suraj. ये वाले. L1 is equal to L1 dot next. Sometimes we do L1 dot next is equal to L2. Yes? We have already discussed in our previous class. So I'm sure you guys are aware of it fully. We have also gone to the inspect element for these two. For these two, we have gone to the inspect element and find it out how the JavaScript assign the variables and the next part. And for this, I think it was very easy. We have understood with the linked list. 1, 2, 3. If L1 is equal to null, it will reach here. Right? And when L1 dot next is equal to null, we'll reach here. So when we do not want to read the last value, when we do not want to read the last node, we'll do always this thing. L1 dot next is not equal to null. When we want to read the last value, we always go with this. L1 is not equal to null. So I hope you guys are aware of this. Remember this thing. So did you guys understood this code? I think I have this code here. Right rotate. Yeah. So see, first I've taken the kth node. Like this is my, in our example, we were taking temp, but here I'm taking it as a kth node. And what we did, kth node is equal to kth node dot next. So we reach to this third element. In this case, we reach to this element third. So that's what happening here in the for loop. They are doing in for loop, right? And then after that, all the remaining nodes, kth node dot next, and then kth node dot next is equal to null. It means this one where we have left it. Same thing. Then we have taken one pointer for reaching to the last node, and once we reach to the last node, pointer dot next is equal to this dot head, and this dot head is equal to remaining node. Here we do not need this actually. Here we can also pass the head. Okay. Okay, guys. So now we can go for break, and then we can come for further questions. Okay, guys. Today it was actually not that much difficult question. It was easy questions. All the codes already there. Okay, so let me, if not there, let me push it. And it is in the LL3 branch. Okay, Suraj, I posted. Can we use module.export to export classes? Yes, we can. Module.export is equal to your class name. Yes, we can. Actually, we have done it many times. Let me show you very quickly in one of my projects. I'm not sure I should show it or not, but yeah, just showing you. It's in the TypeScript. So you can see in the client.ts. I'm not sure we are using module.export or let me check. Oh, we are using export here. But yeah, that's fine. We can do it. This was the TypeScript one, so we are using the export there. But yes, we can do it. Module.export equal to same class name. Yeah, we used in models. Yes, yes, right. We use in models also. We can do that. Okay, guys. So let's. Right now it's 9:38. So we all can come back at 55. We can come at 9:55. We can go for dinner and then we can come back. Okay, guys. So let me put the timer for 15 minutes. Yeah. Before that, is there anyone has any doubt in all of these three questions? I think logic was very simple for them. Code was also very easy. Anyone any doubt? No, right? So let's jump into the let's go for break. So 15-minute timer. Is everyone back? Is everyone back now? So Ankit is asking, is TypeScript little bit advanced? Oh, I could say that TypeScript make JavaScript little bit more advanced because JavaScript is very dynamic language. You know that? Because in the JavaScript, everything happens on the runtime. But with the help of TypeScript, you just added one more feature to JavaScript, which make your JavaScript little bit more secure. Because with the help of TypeScript, you just define like while you are writing the code. Right now, we are just writing let any variable we can assign, right? Let text is equal to, like if we talk about the let temp, we can assign object, we can assign integer, we can assign string, we can assign array into the same variable. Let temp is equal to same variable, anything we can assign. But when you will be using the TypeScript, at that time you can only assign one value in that let temp. If you will say that this variable is going to store a string, you can only store a string on that. If you say that you're only going to store number into that, you can only store the number into that. Yes, it is compile again. Yes, at the runtime. See, after adding TypeScript also, it's not going to make any impact. TypeScript is not going to make any impact on the running JavaScript. While your JavaScript is running, TypeScript is not going to make any differences. TypeScript only helps you while you are writing your code. So at that time, TypeScript like says to you, like you have created this function. What are you returning from this function? You have to return something from this function. And whatever you are returning, you should know that. You should know that whatever you are returning. So these type of constraint, TypeScript put it when you write the code. But while JavaScript is running into your servers or anywhere, at that time TypeScript doesn't matter. Even like at the time, if you are like if you have stored like if you're saying that this variable is going to take a string, but on at the runtime, if that variable is taking integers, still your code will work. Still your code will work at runtime. It's strict while you are writing code. So there is like we will talk, we can talk more about it. How the like yes, but there are many benefits of TypeScript. But we can talk later about this. We can have some more things. No, you didn't miss anything. Okay. So let's jump into our next question, guys. Okay. So let's complete this whole data structure part, Ankit, and then we can have one session on TypeScript. I think in 3 hours would be enough. But yes, 3 hours would not be enough because there are a lot of things TypeScript provides you. But the basic understanding of TypeScript would be enough in 3 hours. Okay, guys. So you guys are able to see my screen now. Yes. So let's jump into the next question. Okay. So in this next question, they are saying that you are given two linked lists A and B of size M and N, and your job is to merge both the linked list in a way. Now the question will become interesting. Merging, you already know that, but how to merge? That's what they are going to tell you. So your job is to merge both the linked list in a way that their nodes are arranged in an alternative position. In an alternate position. Okay. Now, question is not ending here. Question is more. The first linked list will contain the resultant list, while the second has to become empty if all its elements are used. This is not is. If it would be if all the elements are used, else will contain the left out elements. Okay, guys, I know this one is little bit difficult to understand. So that's why let's come back. Let's take it into our OneNote. Let's try to understand it. Okay. And then they are also saying try to perform an in-place insertion. Keep it in the time complexity as O of n. Okay, you know about the in place, right? Where we just need to switch the nodes. We should not take any extra node, right? In earlier question, you remember, right? In the merge linked list, when we did at that time, they specifically mentioned that we can use a new linked list there. But in this case, they are saying try to do it in place. You should not use any new linked list here. Okay. So that was the some constraint they have given. But let's understand the question again. Okay. Let's take this example only. 1357246. Let's take this example. Okay. So our first linked list is 1, 3, 5, and 7. Right? And second linked list is 2, 4, and 6. Now what they are saying, guys, your job is to merge both the linked list in a way that these nodes are arranged in an alternative position. In an alternate position. It means like first one, like it will look like this. Our answer will look like this. 1, then 2, then 3, then 4, then 5, then 6, then 7. You can see all the nodes are in alternative position. Right? And now still question is not ended there. Now they're saying your first linked list will contain the resultant list. So they are saying you have to change these linked list this time. And your first linked list should have this as a result. Your first linked list should have this as a result. So it means after that you have to return your first linked list and second linked list. And your first linked list should look like this. And your second linked list should be empty or null if there is no element. If there is no element, because all of the elements has been already put it here, so that's why there is no element in the null in the L2. But if there is any element left out, you have to add it into L2. So there is another example for that. For the second scenario only, there is another example: 2 4 6 8 1 3 5 6 7. So another example. So L1 length is 2 4 6 8, right? And L2 is 1 3 5 6 7. In this case, they are saying first you need to combine these two linked lists and put them in the alternate position. So L1 will look like this: 2 1, then I think 4, then 3 4 3, then 6, then 5, then 8, and then 6. Now it will stop here because all of the L1 elements we have traversed it, right? So in L2, 7 will be left. So these are the two scenarios, guys, only. In first scenario, you can see L2 is becoming null or empty. Empty also you can say. Or in the second scenario, L2 is there. And your first L1 look like this. Let me see the 2 1 4 3 6 5 2 1 4 3 6 5 8 6 and L2 is 7. Correct. This is the correct answer. Did you guys understood the question now? You have to put your, what is 7? So 7 is the last element which is not added in the L1, which is not got added in the L1 because L1 has 4 elements. So we can only add these 4 elements from the L2. So the fifth element left in the L2. So that's why we are seeing it into our second linked list. Okay, Joseph? But in the above case, it didn't happen. It didn't happen. In above case, it did not happen. Because we just need to check this null and empty scenario for L2 only, not for L1. Yes, definitely. We have done a slightly similar question. Odd and even. I think that's a similar question, right? Odd, even. But it's yes. The problem is here. The problem reorder linked list. Yeah, that one. But just the simple change is here that you need to change everything in L1 only, and whatever the left element is there, you need to have it in L2. That's the just change. Little change is there. So guys, we will not make this question tough. We will take. Let's think about the answer. We will not make this question a little bit tough. But I hope you guys have understood it. You have understood the question, guys? Anyone does not have understood the question? Suraj, Parag, Joseph, Arad. Joseph has understood. Okay. Parag has understood. What about you, Arad? Yeah. Can you explain once again? Sure. So, Arad, what happened in this question? They are giving us two linked lists. You see, L1, L2, L1, L2. They are giving us two linked lists. Now, what they are saying, they have given us, I think, three conditions. Okay. Yeah. Three conditions they have given us. The first condition is you have to merge this linked list and you have to keep the elements in a alternative positions, like this element, after that this one, then this one, then this one, then this one, then this one, and then this one. Okay, this is the first constraint which they have given to us, that you need to merge the linked list and you need to keep the nodes in alternative positions. Understood that part? You understood, Arad, how the alternative things are happening? Okay, so now the second constraint is they are saying the resultant list, like after keeping all the elements in a alternative position, whatever the list is coming, that has to come in L1. So like whenever at the end, when we are returning L1 or the first linked list, so we should get the result in there, in that linked list. We should get the result in that linked list. Understood the second constraint now, Arad? Whatever the final linked list is coming, that final linked list has to come in L1 only, in the first linked list. Understood this part? So it means we need to change everything in the first linked list. Okay. And the third constraint is for L2. They are saying there could be two possibilities for L2. In one case, L2 could be empty if the size of L2 is lesser than or equal to L1. I believe if the size of L1 and L2 are equal, then I think L2 will go to empty scenario. Or if the size of L2 is lesser than L1, then it will go into empty scenario. So there will be two scenarios for L2 for being an empty linked list. So that's what they're saying. If the linked list 2 or L2 linked list is coming as a empty, you need to return L2 as a empty. If not, if there is any element which is left out in L2, you need to return that one also. So that's what you can see in the second scenario when L2 length is greater than L1. When L2 length is greater than L1, in that scenario, we can see one element got left. We were not able to merge it. So that's why we have kept that alone element in the L2. So these are the two scenarios for L2. Now you got it, whole question, Arad? And we need to return the L1 and L2, our updated L1 and L2. Understood now? Anyone has any doubt? Good, right? We are good. So let's now jump into the solution part. So let's take the two linked list here. L1 is equal to 1, 3, 5, 7. L2 is equal to 2, 4, 6. Okay. So now you already know that. Two pointers, already you know that. L2 pointer and L1. Okay. These two pointers, we have already taken it out. So now guys, we can take one more pointer here or two more pointers. Anything you can do. So why we are taking those two pointers? Just to pick, because now we need to change the L1 values, right? We need to change the L1 or L2 values. So that's why we need to have some pointers to keep the rest of values, to keep the rest of values when L2 is here. So keep the rest of values. That's why we have to take, I think let's take two more pointers. Okay, so first pointer is for L1 next, L1 next. This is for L1 first linked list, and L2 next. This is for L2 linked list. Okay, and this pointer will only help us to track the next element, to track the next element in our linked list. Okay, so now we have two pointers. So let's start our loop. Let's start our loop. And I think our loop will start from any one of them, L1 or L2, any one of them becomes null. Any one of them become null. So yeah, our loop will again start with like this. While L1 is not equal to null, and L2 is not equal to null. So when any one of them become null, we will stop it. Okay. Now let's see that. So first what we'll do, guys, in the L1 next, we'll keep all the next element of L1. All the next element of L1. So how will look like? L1 next is equal to L1 dot next. Correct? So now L1 next will be pointing out here. Am I right, guys? Now L1 next will be pointing it out at this place. Right, guys? Same we'll do for L2 also. So L2 next is equal to L2 dot next. Correct, guys? Now L2 dot next or L2 next will be pointing out here. Correct? So now these both elements are free. Now these both elements are free. Correct? Now we can add anything into that because we have for all the remaining element, we already have the reference L1 next, L2 next. We both have reference for that. Till now we are good, guys. We already have the reference for both of the linked list, right? Are we good till now, guys? Yes, right. So now what we need to do, guys? See, once we are adding this L2 to L1, we need to remove this. We need to remove this. So what we'll do, guys, in the L2 dot next, 1 minute. Let's think about it. What we need to do? 1 to 2. Yes. L1 dot next equal to L2. Yes. L1 dot next equal to L2. Sorry. So now this is our L1, right, guys? This is our L1. So now let's just, I'm thinking. Yes. I think yes. Yeah. Let's see. L1 dot next is equal to L2. So once we'll do this thing, guys. Once we'll do this thing, so our linked list will look like this: 1 and 2 and 4 and 6. Am I right, guys? Our L1 will be here, right? It will look like this because we have added whole linked list L2 in the L1 dot next. Correct? Right, guys? Did you understood this thing? After adding this line, this will look like this. Everyone understood? Let me know in the chat. Arad has understood. Suraj has understood. I think Arad has said yes for earlier. Okay. Once again, yeah. So once we did what we did, Joseph. Right now we are here, right? At the first pointer, and we are here, L1 and L2. With the first line, this is line number 1, this is line number 2, this is line number 3. With the first line, we have assigned L2 dot L2 next and L1 next to the remaining element, to the remaining linked list, you can see. So L2 dot next is equal to L2 dot next, you can see. L2 next is equal to L2 dot next, and L1 next is equal to L1 dot next. So now these two pointer already have the reference for these remaining nodes. Correct? So now we can change this value. We can change L1 also, we can change L2 also. We can change L1 also, we can change L2 also. So that's what I did. L1 dot next equal to L2. So after this node, all of L2 node will be added 1 to 4 6 like this. Correct? Because now L1 dot next is equal to this whole linked list is coming there. Got it, Joseph? L1 dot next equal to L2 means whole linked list of L2 will be added into the next of L1. Correct? Okay. Now what we need to do next? Now what we need to do, guys? Next, we need to move our L1 now. We need to move our L1 to 3. We need to move our L1 to now 3. Correct? So now move our L1 to L1 next. L1 is equal to L1 next. So now this L1 will be moved here. Now this L1 will be moved here. Okay, okay. L1 is here. Now we need to think about L2 also. We need to think about L2. What we need to do L2? Because we need to delete this 2 now. From the L2, we need to delete now from the list 2. This is list 2 and this is list 1. Right? These are L1 and L2 pointers. So that's why I made it list, because you guys may say that this L1 and L1 are both are equal. No. This is list 1, this is list 2, and L1 and L2 are pointers. Okay? And right now our list is looking like this. List 1 is looking like this. Our list 1 is looking like this. Correct? Sorry, this is L1, right? Oh, we have already moved our L1. So now, yeah, L1 will not be there, right? So now our list 1 is looking like this, and list 2 is looking like still looking like this, 2, 4, 6. So now we need to delete this 2 here. So what to do there, guys? I think first move our L2 to here. Yeah, that is definitely needed. So L2 is equal to L2 next. So now L2 pointer, I am not right now talking about L2 pointer. So now L2 pointer is this place. Now we need to delete this element from list 2. What do you guys think what I need to do here? How can I delete this element from here? From my list 2. L1.next does not it mean 2. L1.next does not mean 2. L1.next does not mean 2. L1.next does not. Yeah, after doing this, like if we are in this line, after this line, if we will do L1.next, then we'll get 2. Understood, Joseph? After this line, after line 3, if you want to print L1.next, we'll get 2. Yes? But I'm not doing L1.next. You can see this is L1 next. This another pointer. L1 is equal to L1 next, not L1 dot next. This is the pointer, not dot. Got it? Okay, so now I was asking how to delete this thing. How to delete this 2? Any ideas, guys? How to delete this 2 from the list 2? From the list 2, how to delete this 2? We already have 4,6. We already have 2 references for that, L2 and L2 next. We just need to delete this 2 from list 2. What should we do? I think we can say that list 2 is equal to L2. Will it work? Yeah, I think this will work, right? Now we will not have any reference for 2, because our list 2 will now start from 4. Guys, is it correct? If I want to delete this 2 from the list 2, will this line correct? Is it this line correct? Let me see in the chat. So Ekta says yes. What about others? What about others? If I want to delete 2 from the list 2, if I make list 2 is equal to L2, so now list 2 will move here. So I think 2 would be deleted. Yes, Arad is saying it will work. Okay. Okay. Let's dry run it. Let's dry run it for everything. Okay. So first thing we have already done 1, 2, 4, 6. Now from list 2, 2 has been deleted. Okay. Now let's move again. L1 and L2. L1 L1 is equal to null. No, L1 is at 3. L1 right now pointing out this linked list 357. Okay. And once we'll do 1 minute. Okay, guys, one problem is there. Now, see, now if I do L1 next is equal to L1 dot next, so this 5 7 will come there, right? Now L1 dot next will be this place, 5 7, correct? And then L2 dot next would be at 6. Okay, okay, fine. Then I am doing L1 dot next is equal to L2. L1 dot next is equal to L2. You know what I'm doing? I'm doing 3 to 4. 3 to 4. You guys get it? What I'm saying? 3 to 4. But this is wrong, right? We need to do 2 to 3. 2 to 3. So that's why, guys, this line is wrong. This line is wrong, it seems like. We can't do this. Or if we can do this, I think we can do this, but we cannot do this. Yeah. I think, let's think about it. We can do this, guys, but we can't do this. If we'll do L1 is equal to L1 next, we can't. I think here it should be L1 is equal to L1 dot next, which Joseph was telling also. It should be L1 dot next. Now L1 should come at this place, 2, because after that we will add the this one, 4. I think I'm missing something, guys. After that, what we need to add? After 2, 3 should be added. This 3. Then I think 4 should be added. Okay, 1 minute, guys. I think I'm missing something. Mm-hmm. Okay. So 2 is there and 3 is there. Okay. See, something is missing, guys. Did you guys the problem? In the end, if we return list 2, will only return what is the left? Yes, that's right. But see, something is missing in that logic, guys. And that part is we are not able to properly traverse it. We are not able to properly traverse it. Something is missing here. So see, our output should be like this. 1, 2, then 3, 4, right? 1, 2, 3, 4, correct? But after one loop, it's not happening. So 1 minute, 1 minute, guys, sorry. So what is happening here? We should be having one pointer here at the after the adding 2, and then we should add first one element from here and then one element from here. Something like this it's working, looking like. Let's think about it. So L1 is here, L1 next is here. Okay. Okay, one more idea is coming into my mind, guys. One more idea is coming, and that looks like if we add, like if we start with this, like this, 1, 3, 5, 7, null. This is our L1, and L2 is equal to 2, 4, 6. You guys tell me if that will solve us or not. So I'm thinking if I add L2 dot next is equal to L1, L2 dot next is equal to L1, L2 dot next is equal to L1. So 2, 2 will be added to 3, and then I will add it to 1. Yes, let's try with that way, guys. Let's try with that way. That way, yeah. So see, this is our list 1. Again, guys, the previous approach has little bit problem. So I'm trying. I know. I think. Let me first ask. You guys understood the problem there? You guys understood the problem in the first approach? What was the problem there? Because we were missing the 3 part. We were missing the addition part. So that's why we'll go for the next approach. And which is, this is our list 1. 1, 3, 5, 7, null. And this is our list 2. I think this should work. 2, 4, 6, null. Same while condition. Same while condition. L1 and then L2. If both any one of them is null, just give me. And now 2 pointers. So 4 pointers. In one way, 4 pointers. L1, L2, next L1, next L2. Or if you want to take temp L1, temp 1, temp 2, that's also fine. Next one, next L2. Okay. Now what we need to do, guys? Yeah. So what we need to do, guys? So first, take the next of L1. So next L1 is equal to L1 dot next. Okay. Now here our next L1 will be. Next L1, it will be here, right? Now also take the next L2. L2 dot next. Right, guys? Now here, next L2 will be. Now what we need to do, what I'm saying, I will take this one and this one first. This one and this one. And then I will add in L1. Okay, so what does it mean? It means L2 dot next, L2 dot next is equal to L2 dot next is equal to NL1. Yes, L2 dot next is equal to NL1. Okay, so now once we will write this line, so it will look like this: 2, 3, 5, 7. 2, 3, 5, 7. Right, guys? Let me know in the chat. This line you guys understood? 2, 3, 5, 7 null. Everyone? 4, 6 is lost. 4, 6 is lost. Joseph is saying 4, 6 is lost. No. 4, 6 is in NL2. 4, 6 is in this one. NL2. 4, 6, just say 4, 6 is with this pointer. Next L2. We can access 4, 6, right? Already taken it. Right? Yeah, we already did it. Okay, now once we did it, now we did it. Now add it into L1. L1 is equal to L2. Yeah, L1 is equal to L2. Let's think this will work or not. L1 is equal to L2. So now once we run this line will give L1 is right now at 1. So 1, 2, 3, 5, and 7. Right? And now all of this already we have taken in next L1. Guys, looks correct, right? L1 is here right now. Looks correct, right? Looks correct, right? L1 is equal to L2. Now 1, 2, 3, 4 is there. Everyone agree with that? Let me know in the chat, guys. Everyone agree with that? Or we do need to do any other thing? Yeah, I think L1 is equal to L2 will. But yeah, let me first you guys tell me. L1, L2 looks good. Yes. Now what we need to do next? Now the next thing which we need to do, we need to move our L1 to where? Oh yes, we need to move our L1 to 3 or 2. That's what I'm thinking. Where we need to move our L1? No. What I did here, L1 is equal to L2. What I did here. Wait. L1 dot next, guys. L1 dot next is equal to L2. Not L1 is equal to L2. L1 dot next is equal to L2. Then this will be added here, right? Yeah, this will be the time. Yeah, that's what I'm thinking. What should we do now? No. I think we need to move L1 also, right? So where we need to move our L1? First, I'm thinking about L1, where I need to move, because L1 dot next, L1 dot next. So next time I think I will move my L2 to here 4. So for 4, 5 will come, right? For 4, 5 will come. Yes, for 4, 5 will come, and yes. So guys, definitely I need to move our L1 to NL1. Next L1. Yes. I need to move our L1 to next L1, which is 3. Which is 3. So my L1 will move from here to this place. My L1 will move from there to this place. 1, 2, 3. And then now I need to think about the L2. So now I can simply move my L2 to NL2 or anywhere. NL2 is equal to L2 is equal to NL2. So L2 will be moved here. L2 will be moved here. Right, guys? And then I need to delete this thing. So this would be list 2 is equal to L2. List 2 is equal to L2. Did you guys understood these two lines? These two lines are, but yeah, first let's do the dry run. Then we'll see this will work or not. So now right now our L2 is here and L2 is here and L1 is here and L1 is at 3. Now let's think about it again. Next L1 will move to L1 dot next. So now this NL2 will be at this place, NL1, and then same for NL2 also. This NL2 will move here, NL2. Now let's see these lines. L2 dot next. It means 4 dot next is equal to NL1. Means 4, 5, and 7. 4, 5, 7. Correct. 4, 5, 7. Totally right. Then L1 dot next is equal to L2. L1 right now at 3. So 3 dot next is equal to 4, 5, 7. Correct. 4, 5, and 7. Totally right. 4, 5, 7. Correct. This will be added after 4. You can see 4 is here at L1. Correct. And then we are moving our L1 to next L1, which is 5. So it will be moved here. L1 will be moved at here. Means L1 will be moved to this place. Correct. L1 will move to here. I think we can use one pointer only. No need to use actually an L1 and NL2. But yeah, we'll see. We'll see. Wait. And then we'll move our L2 also here. And then from list 2 will also come here. Right? List 2 is equal to L2. All 3 pointers will be here. Now again, same thing. Again, same thing. And L1 will go here. Again, same thing. And L1 will go here. And NL2, this line, NL2 will go to null. NL2 will go to null. Right, guys? NL2 will go to null. Then L2 dot next equal to NL1 means 6. Now this 6 will be moving to 7. And then again, L1 dot next equal to L2. So after 5, 6 and 7 will be coming here with null. 6, 7 and null. Correct? 6, 7 and null will come here. Then L1 is equal to next L1. So now L1 will again move from here to here, right? And L2 will be moved to, L2 will be move to, first L2 will be moved to NL2 here, and then list 2 will also move there. Then list 2 will also be moved there, and list 2 will be here. And here our loop will be ending, and then we can simply return our list 1 and list 2. Yes. So this is the code actually, guys, will work. Let me know in the chat where you guys face problem. Last two line, repeat. Last two line, right? These two, right, Suraj? These two. So in these two, we are just moving our L2 and list 2 because we need to delete that element from the list 2. This is our list 2. We want to delete 2, 4, whatever element we have merged it. We need to delete these things. So that's why I am just moving my list 2. If I will not move my list 2 will still point to 2. List 2 will still point to 2, and 2 will always point to 4, 4 will always point to 6, and our list 2 will never be deleted. From the list 2, this element will never be deleted. So that's why I'm moving my list 2 also. And for L2, I'm simply moving wherever my next element is. I'm just simply moving my L2 to that place. Okay, Suraj? After 3, it's 4. After 3, it is 4. Which line you are talking about, Joseph? List 2 is equal to L2. List 2 is equal to, yes, that line already written it here. List 2 is equal to L2. Correct? Guys, you want to try this with the second example also? I think we have the logic in our code as well. Let me check there. Merge 2. Yeah, the merge 2. You can see here, we have taken 4 pointer, current L1, current L2, next current L1, next current L2, right? And then I'm checking current L1 is not equal to null, current L2 is not equal to null. In the next current L1, first I'm taking all of the next of current L1. In the next current L2, I'm taking all the next of current L2. Same thing, right? Same thing we hear also these two lines. Same thing happening here also. And then current 2 dot next is equal to next current 2. Yes, that was the logic only. Current 2 dot next is equal to next current L1. And then current L1 dot next is equal to current L2. Let me see. Yes, L1 dot next is equal to L2. Correct. And then current 2 is equal to next current 2. Current L1 is equal to next current L1. Yeah, I think these two lines. And then they are simply moving our head. L2 dot head is equal to current 2. But yeah, it's similar. It's same. If you are having a head also for L2, we can move that also. Otherwise, we can simply do list 2 is equal to L2. List 2 pointer will also move. We just need to change our head for list 2. See guys, when we are doing list 2 is equal to L2, automatically its head is changing, right? Earlier its head was here. So but when I'm moving my list 2, so automatically head will change, right? Head will go here, head will go here. So that's what they are doing. L2 dot head is equal to current L2. Same line. Did you guys understood now? Anyone has any doubt? Arad, Suraj, Joseph, Nilanjan, anyone? Did you guys understood now? Let me know in the chat. This problem seems hard. Okay. Try run with other examples, sir, for more understanding if possible. Can you show me? Sure, sure. Not an issue. This is the code, Ekta. Okay. So now let's try run it with another example. And Arad, I was saying it's not difficult. If you should be having good visualization here. So now let's take another example, okay? For the dry run. What was that? Another example was L1 is equal to, yeah, this one, 2468. 2, 4, 6, 8, and it's pointing out to null. And 1357, yeah, 13567. So L2 is equal to 13567. So see, Arad, it just we are taking more pointers here. It just we are taking more pointers here. That's what it is looking to you little bit hard. Otherwise, it's very simple. It just you need to move the pointers with your visualization. Okay, so let me tell you how the pointers are moving here. This is list. This is list 2. Okay, so I'm taking 2 pointers for this thing, for list linked list 1, and 2 pointers for linked list 2, L1 and temp 1. Right now I'm not taking L1 left, something like that. L1 next, temp 1, and for this one I'm taking L2 and temp 2. With this exam, with these pointers, are you guys okay? Oh, you connection by loop again, just not getting code. Okay, with these two, we are first let's dry run it, then we will jump into the code also. So now this L1 is pointing to head. So now L1 is here and L2 is here. And this temp 1 and temp 2 are null. Okay. Now let's start the moving part. Okay. So let's start from L1. So what I'm doing here, all of the remaining element, all of the remaining like 4, 6, 8, we'll keep it into temp 1. So for that, we'll put our temp 1 here. So once we'll do the console.log temp 1, we will be getting all these elements. Same we will do for temp linked list 2 also, temp 2. Did you guys understood? Did you guys understood now? Temp 1 and temp 2 there. Understood now? Yeah? Okay. So now what we are doing, now a little bit just twist. So first we will add L2 dot next is equal to 4. L2 dot next is equal to 4. So 1 and 4 will be come together first. 1 and 4 will come together. So L2 dot next is equal to temp 1. Okay. So 1 or 1 comma 4 will be added here. After doing this, I am adding this combined result. This combined result into L1. So that's what. So after we'll combine it, so it will look like this: 2, 1, and 4. All these 2 steps which we did, it will be look like this: L2 dot next is equal to temp 1. So once we'll do this, this line will be completed. 1 say 4. This relation will be created here. And then L1 dot next is equal to L2. So this link will be created. Did you guys understood these 2 lines now? Did you guys understood these 2 lines? Arad, Suraj, Joseph, understood this? Okay. So now you can see 214 is there, right? Now we have to move our L1 and L2. L1 and L2 are still in there. L1 and L2 are still in the same place. L1 and L2 are still same place. We just change the next values. You can see everywhere I'm just changing the next values, not the L1 and L2. So now we will change the L1 and L2 also. So now I will put L1 is equal to temp 1. So this L1 will be moved to temp 1. Now this L1 will be moved to here. And same for L2 also. Okay, same for L2 also. So for that, what is the code? L2 is equal to temp 2. This is the code. These are the 2 lines for transferring our pointers. Okay, did you guys understood these things? The next 2 lines, did you guys understood? Yeah, understood? Okay. Now what we need to do, there was one more step. They have told us that we need to delete the element from the list 2. We need to delete the element from the list 2. Because right now list 2 head is still at this place, right? List 2 head is still at this place. So we need to change this. So what we can do? We can do this also. List 2 dot head is equal to L2, or simple list 2 is equal to L2. Any of these two lines. Any or this is or any of these two lines. So these two lines will move our list 2 head to here. And this number or this node will be deleted from list 2. So that's why this was the last line in the code you guys are seeing this. L2 dot head is equal to current L2. This is the last line that was just moving our list to head to further. So next time if you will print the list after, see, after this line, if you will print the list, it will look like this: 3, 5, 6, 7. But before that, before this line, this is after and this is before. Before this line, your list 2 will look like this: 1, 3, 5, 6, and 7. Understood, guys? The difference would be what would be the difference this particular line will make? This particular line, these two, or any one of them, these difference that these lines will make. Now you guys understood? Suraj, Arat, but we have already taken away one. So where? In which line, Joseph? You tell me. In which line we did that? There are, you can see, 1, 2, 3, 4. These are the 4 lines. You tell me in which line which we did that. 3 and 4, right? So 3 and 4, let's see. In the 3 and 4, we are moving our L1 and L2 pointer, not the list. I told you, right? L1 and L2 are the pointers. Temp and similar like temp1 and temp2, not the list. List has his own head. List 1 also has his own head. So we are using L1 and L2 just like a pointer to go from one node to second node. So we already did get away from one by reassigning head 2. Yes. So we just reassign our head 2 to the second node. So now our head 2 will always point it out from the second node, not the first node. Now that first node is deleted from the list 2 because its head we have moved. Once, see how we know that from where our linked list is starting? With the help of head only. So once we are moving our head to another node, it means now that's the head. From there only linked list will start. That's why L1 and L2 are just the pointer, not the linked list. Understood, guys? Everyone now understood? And now you guys see this is the same code. These are the, I think, how many lines? 4 lines, those. This is a 5 line. And these lines just for assigning the values of next. Yes? Was it difficult or hard? Totally got it? Okay. Now let's move into our assignment question, guys, quickly. So these are the 2 assignment questions. I think the first one you guys already aware of. Reverse the node of given linked list. We have already discussed this problem, right? No problem, Arad. This is the linked list. It happens. It just needs little bit visualization. That's why first do the visualization, then go for code. So I think reverse the linked list. We already know that, right? So we can go for next assignment question, which is also very easy, not difficult. And the question is, you will be given a linked list, move its last element to the front position. Very easy, right? We have one linked list like 1, 2, 3, 4, 5, and 6, and null. We need to move this last position to the first position. Means our output should look like this: 6, 1, 2, 3, 4, 5. I want you guys to think about this. This is very easy question. First, let me know in the chat, did you guys understood the question? Last node has to be first node. Did you guys understood this question? Everyone understood? Last node, this is our last node. This node should be the first node. Everyone understood? Now you guys tell me the ideas. Do the visualization. So let me give you one hint. First, we need to reach the last element. First, we need to reach the last element. This is the first idea, first hint. Okay, let me give you one more hint. We also need to reach to previous element. This is the current or this is the previous. We need to reach to current and previous. Now I have given you more hint. Now you should tell me what should we do. So last node dot next to this dot. Totally right, Ekta. Totally right. But one line you are missing. Ekta, in your case, one line you are missing. These two lines are definitely needed. One more line is there. With the help of previous node to make it null. To make it null, what, Joseph? Previous dot next. Yes, previous dot next equal to null. That's totally right. Okay, so once we do the previous with null, so 5 will become null. Like it will look like this. Our linked list will look like this. 5 and null. But this is not our answer, right? Our answer is this. What else? We have to go till last one only. Yes, we have to go till last one. Yes, yes. Previous dot next is equal to head. Okay. Arad, if you will do the previous dot next is equal to null, next is equal to head, you will create a cycle. You see, you will reach till here. 1, 2, 3, 4, 5. This is the previous one, right? And previous dot next is equal to head. It means you will create a cycle here. Yes, yes, Ekta. Now your answer is correct. All three lines will be needed there. Arad, you understood? Like the line which you written, it will create a cycle there. Understood, understood, Arad? It will create a cycle there. Okay. So see, guys, the idea is here. We need to reach to last element, and before that also, last element or second last element. We need to reach there, previous element and there. Then the next line would be current or last element. Let me write the correct word, last. This is the last, right? Last element. So last node dot next is equal to head. Is equal to head. Last node is dot next is equal to head. And before that, previous dot next is equal to null. Previous dot next is equal to null. Now this will not make cycle. You see that 1, 2, 3, 4, 5. With this line, 5 is pointing out to null. Now we have 6 at the last pointer. So what we are doing? 6 dot next is equal to head. So head is this, right? So 6, 1, 2, 3, 4, 5 and null. And then we'll make this last node our head. So head is equal to last node. Because till now our head is 1. Now we'll move our head to this one. So now this will be our final answer. So these are the 3 lines only, guys, which you needed in your while loop. In your while loop, you will check like this. While last dot node, let me write it correctly. While last dot next. Why we are doing last dot next this time? Because we do not want to read this value. We just want to go to that pointer. So that's why last dot next is equal to null, is not equal to null. And then previous is equal to previous is equal to last, and last is equal to last dot next. Right? Last equal to last dot next. So now we'll reach this position where previous will be here and last will be here. And after that, all these three lines. All these three lines, previous dot next is equal to null, last dot next is equal to head, and head is equal to last. Head is equal to last. I hope you guys understood this. Anyone has any doubt? Anyone wants me to explain it again? Suraj, Arad, Joseph. I'm not sure about others because I'm just seeing these 4 people reply from very long back. Arad, Joseph, and Ekta, and Suraj. These 4 people are only responding. But I think in our chat, 20 people are there. I'm not sure why people are not responding here. What about others? I think Likhit was there. Not sure Likhit has left the chat. What about others? Ankit was there. Yeah, Ankit is also not responding now. Parag is there. Yeah, Parag, you understood? The last one. You want me to explain any line again? Got it? Very nice, very nice. What about others? Like, not sure. Najmeen has joined. I think the first person today. Najmeen has joined. Is Najmeen still here? Sarad was there. I remember some of the names I'm getting right now. Sarad was there. Nilanjan is there. Yes. Sir, I'm facing a lot of internet issue today, so unable to attend class properly. Will watch class again. Very sad, Nilanjan. We are talking a lot of interesting questions, and today's question was very easy actually. Lost my connection for a while. What was the question? The question was this actually. We have a one linked list. I think you have already given the answer, right? Yeah, same question. You have already given the answer. So I was just asking. Yeah. Okay, what about others? Ankit is there. Okay, I need a lot. I need a lot of work specifically on linked list. Oh yes, Ankit. Actually, uh, see, try to spend some time. I think somewhere you are missing. I'm not sure which part. Like if you want to connect to me on one-to-one on LinkedIn, we can connect like on the next week because weekend I am like after holidays only. So I can hear your doubt also. Or I think if we have any revision class on that day, you can talk to me. I think, see, you are missing somewhere in assigning values. When you read about, when you last time mentioned your comment, this dot next, this dot head, this dot null, at that time I understood that you are missing somewhere in assigning value. You are confused in somewhere assigning values. But but why are you confused? You just try to traverse one simple linked list. Take a simple linked list. See, linked list is nothing. It's just object. Every node is an object, and every see in linked list every node is an object, and in that object you are connecting to different. See, let me show you very quickly. Like if you want to visualize the linked list in the code, it looks like this. This is the first node I'm saying, node 1. Node 1 is equal to this. So value is equal to value. This is the object, right? Value 4. And then next. Next has again one object there, which again have val is equal to 5. And then we again has next, which again has one another object, val 6. This is how linked lists reside in memory. And then in next, we have the null. The same linked list, we draw like this. The same linked list, we draw like this. guys, 4, 5, 6 and null. The same linked list we draw like this, it looks like this in memory. It looked like this in memory. So Ankit, try to understand all of your variable assign. Like when we assign head is equal to something, or when we do head is equal to head dot next, try to do with this. Okay, Ankit? So first create this object and then simply try to traverse it. Head is equal to head dot next. Check in head, what value will come now. Put your console there, check for that. Once you will understood this thing, then only these variable move, like how the pointers are moving here and there, you will very easily understand. Okay. Same goes for whoever is not able to understand till now the linked list. Whoever has not understood till now, please try this way. I also tried the same way actually. That's why I know that that how the pointers are working. See, I was very confused in one place on this line actually. Node is equal to node dot next. I was very confused in this one. Node is equal to node dot next, and when we do node dot next is equal to something like 5 or node 2, something like this. When we do this, I was very confused in these two, but I tried to understand with this approach, and then I get to know that how these two lines work. How many places actually, Deepak, there are many places actually we are using a linked list. Like in the real world, if I talk about, see, linked list is a core data structure. Linked list is a core data structure. So I'm not sure, like might be like a lot of queues, wherever we are creating the queue stack, or somewhere the B tree structures, like our folder structure. All you can consider about our folder structure in the system. In our system, we have folder structure that could also be implemented with a linked list. But generally, we go with the trees. But similar like it, linked list could be working. See, just understand the concept. Linked list says that you have multiple nodes and you can connect those multiple nodes, and then you can keep those multiple nodes any place in your memory. So wherever you think this thing is happening, you can use linked list everywhere. Queue, stack, both can be implemented with linked list. Galleries, I think so. A lot of places linked list could be used. It's not one or two places. Like folder structure could be the good example. Let's look into the internet also. Like in the real life example, if you want to know about the real life example, then I think the blockchain. If you, because you have already seen the blockchain, right? In blockchain, we can say they are using the linked list only. All the nodes are connected with each other in the real, like in the real life example. But in the system level, lot of places they are using the linked list. Let's see that linked list examples. Linked list real life example. See the previous and next page in web browser. Previous and next page, they can keep it into the node, and then you can go back to the previous. See, I think this would be the doubly linked list. For using the previous and next pages, they can use the doubly linked list. They can quickly access that. Right now I'm in the one page. That would be the page value. Page URL would be page value. Then you will have 2 pointers. Go to the back page or previous page. Doubly linked list would make sense here. Let's see one more. Like in the Stack Overflow, if they are giving any answer. Conga line. I'm not sure about the conga line. What is that? Okay, so they are saying like during a Christmas disco, they have some conga line. So that's also looks like similar to linked list. Not sure about that. Everyone holds the hips of person in front of them, and their hips are held in turn by person to their rear. You can read about this, but yeah, I'm saying that there could be many examples with the linked list. Okay, guys, so that's all from today class. I think we are ending today with the everything is going to complete in the linked list. And today's very nice or easy examples we had. So now we have, I think, long weekend, Saturday, Sunday, Monday, 3 days. Do not read any of the like previous module subjects like Node.js implementation. Do not read that. Please start your practicing from linked list, stack, queue. Try to solve all the problems, whatever we have covered in our class. Try to solve all the problems in these 3 to 4 days. And then go for lead code, try to find there as well. In meanwhile, if you guys stuck anywhere in the LinkedIn, you guys can post your queries there. Okay. Yes, please revise linked list, stack and queues. Happy Deepavali, everyone in advance. Please enjoy, everyone. Be safe because you guys know why I'm saying that. So be safe as well and enjoy your vacations. Enjoy Diwali. Thank you, guys. Thank you. Happy Deepavali. Happy Deepavali, guys. And anywhere you guys stuck, please use the LinkedIn group. I will only respond there. Okay. Okay, guys. So bye bye. Have a nice day. We'll meet. We'll talk on. I think I'm not sure which day, Wednesday or Tuesday might be. 26. Okay, 26. So I think on that day also we have a lot of problems. I think on the queue or might be in the stack. So please come with your please come with all of your like fresh memories about the queue or stack. We are going to solve the queue and stack problems. Okay, guys. Bye bye.